Okay, welcome to Astronomy 305, Life in the Universe. Second lecture, we're going to start talking about chapter 2 from the book. So let me go ahead and share my screen. All right, so today we're going to talk about science of life in the universe, specifically about ancient science, about how the ancient Greeks set the stage for what we think of as science today. And I always like this picture here from the book. Imagine the trust in science and physics you have to do what this person here is doing, to get out of your spaceship, get into your spacesuit, be completely detached from the ship, and essentially trust in physics, trust in gravity, trust in angular momentum, that you understand all of these things well enough that you know that you can leave your ship and come back to it later on. And so throughout this course, we'll be talking about how science works and how we come to that level of confidence. But we're going to start a few thousand years ago with how the things that we call science today, how they came to be, and in particular, how we understood our place in the universe. Okay, so I'm going to start with an ancient Greek thinker, Thales of Miletus. Lived about 2,600 years ago, and Thales really set the stage for basic, how to think about science, how to conduct the process of doing science, and he basically put down three principles that really, as scientists today, we still follow. Essentially, these three principles are: number one, the universe, everything around us, it's understandable by humans. It is not beyond human comprehension. We can understand these if we work hard enough. And in particular, that things happen through natural causes, not supernatural causes. The river didn't flood because Zeus did it. There were natural things that led to the river flooding. There's a natural explanation, not a supernatural explanation for why things happen. Number two was the use of mathematics. The idea that mathematics can be used to describe how things work, that you can make predictions using a mathematical description of how the universe works around you. And most importantly, the importance of observations, that you can come up with any crazy idea you want, but it's not valuable unless it agrees with observations. If you come up with an idea that makes a testable prediction about what will happen in the future, and that prediction is wrong, you have to work on that idea some more. It is not ready. You need a theory of the world that agrees with actual observations. Okay, so I'm going to go through one example of these lines of reasoning, combining observations with mathematical models to learn something about the universe around us. So hopefully most of you know the Earth is round. The Earth is mostly a spherical shape. And this was, first hypothesized in Greek culture about 2,500 years ago. Pythagoras, who you know from his work on triangles, first suggested that Earth was a sphere about 2,500 years ago. And then a mere, 300 years later, about 2,200 years ago, a Greek thinker, Eratosthenes, figured out how to actually measure the circumference of the Earth. Knowing the Earth is a sphere, well, how big is that sphere? Did an experiment involving looking at the sun from two different locations, a known distance apart on Earth's surface, and figuring out the angle the sun was in the sky at those two different locations at the same time. And based on that, was able to measure the circumference of the Earth to within about 5%. And that's pretty good. So at that point, the size of the Earth, the shape of the Earth, is known from, again, careful observations and combinations of observations and math. Okay, and you can imagine what this means for Greek society. There are maps of the known world at the time, and it was very easy to show that those maps are very incomplete. There's a lot more to the Earth's surface than was shown on maps at the time. There is more of Earth than currently known. Okay. Sort of the next big leap forward in this case came looking at the moon. And in particular, I want to highlight the work of one of the great Greek astronomers, Hipparchus. Hipparchus lived a little over 2,000 years ago. Did a lot of wonderful observations and analysis when it came to astronomy. Created very detailed star catalogs. Measured something called the precession of Earth's axis. And important for us today, he studied the motion of the sun and the moon. And so the way you can tell an astronomer is very well regarded in the astronomical community is when we name a space telescope after him. And so this is Hipparchus the human. This is Hipparchus the space telescope. It launched about 30 years ago, measured the distances to stars using a technique called parallax that we'll come to later on in this lecture. But again, Hipparchus, a really, very well regarded, very good astronomer from antiquity. All right, so what did Hipparchus actually do to study the moon? Well, he was able actually to measure the distance to the moon to pretty high precision. Again, using geometry, using observation of the moon at different points in the moon's orbit from different locations on Earth, he was able to figure out that the distance from Earth to the moon had to be somewhere between about 60.5 and 61 times the radius of the Earth. And we can check his work now. We have these numbers. We can look up the distance of the moon in kilometers. We can look up the radius of the Earth in kilometers, divide those two by each other, and you get about 60.3. So a little bit outside of Hipparchus's range. He said 60.5 to 61. We got 60.3, but that's still pretty darn close for 2,200 years ago. And so if you ask, what did the local universe look like to Greeks like Hipparchus? Well, it looked like a pretty accurate picture. The Earth is a sphere. The total surface area of the Earth was much larger than anything that had been mapped at the time, and so there's much more of Earth yet to be discovered. The universe outside of Earth, mainly empty space. There's a really big gap between the Earth and the moon. This, you see pictures like this of the two objects side by side, but this is a really more accurate picture of what it looks like. There's, again, 60 Earth radii between the Earth and the moon. And so a lot of empty space just to get from the Earth to the moon. And so I asked this, somewhat provocative question. If you were a Greek living about 2,000 years ago, you'd read the work of Hipparchus and other Greek astronomers and thinkers, would you be surprised seeing these pictures? And the answer is obviously yes. If you show pictures to anyone in the Iron Age, that you have to explain what a camera is and where pictures come from. But once you get past those basic points, the physics, the sizes here will probably make sense to someone who's read the work of Hipparchus. You have to explain what country this flag belongs to, why this gentleman is wearing the spacesuit. But again, the size scale of the moon would probably look about right. The size of the Earth in the background would probably look about right. The basic picture is consistent with what was known at the time. So I always like to start out that little story about how the Greeks got a lot of things right. And throughout this lecture, we're going to take a little bit of a left turn into the things that they got wrong. But some basic things they were able to figure out through careful observations, careful math, careful analysis. And we'll continue with that theme throughout this lecture and throughout the course as well.